So students, today we will learn what is resistance and the connections of resistance in electrical circuit and network and types of connections and the resistance what we are going to study that law of resistance means on which factor or matter the resistance depend. So first let us start with the starting that what is resistance. As it the meaning of resistance, resist means oppose. So resistance means the opposition capacity of a particular thing. So as for the electrical engineering is concerned, so we we are saying that current is flowing through a conductor. That means some electrons are flowing. Flow of electrons is known as current. So that flow of electrons is opposed by the conductor's virtue of nature, that is called its resistance. So as a whole we can say that a resistance of a conductor or resistance of a conductor can be defined as it is the property of the materials by virtue which it opposes the flow of current, which opposes the flow of current. So it is the property of the material means we are having different types of conductors like copper, like aluminum, like silver, iron. So different materials have their own property of opposition. So that's why it is defined as it is the property which opposes the flow of current is called its resistance. So we the resistance, as you know that as per Ohm's law that voltage is directly proportional to the current and voltage is equal to product of current into resistance. So the resistance is the ratio of voltage by current, what we have shown. It is the voltage by current, and the resistance the, the resistance we symbolically we symbolically we so we'll say that the resistance is the ratio of voltage to the current, and it is on which factors and all resistance is depending. So that is called the law of resistance. So this is law of resistance. That means the resistance of a conductor is directly proportional to its length and inversely proportional to its area of cross-sectional area. So R is proportional to R. We represent the resistance by letter, we represent R. R is directly proportional to L by A. If we remove the proportionality constant, we will get R equal to rho into L by A. Rho into L by A is where process R equal to rho into L by A. Rho this is your specific resistance of the conductor. It also depends upon the temperature. That's why I have mentioned it depends upon the length of the conductor, cross sectional area of the conductor, the nature of material of the conductor, and temperature effect. If the area of cross section is high, then obviously though it is inversely proportional, obviously the resistance is low. If the length is more directly proportional, since the length is directly proportional, if the length is more, obviously the resistance of that conductor is high. Now we'll go to the types of connection we have. Mainly we are having in electrical engineering many types of connections, but in basic electrical what we have to learn, mainly there are two types of connection. One is called series connection, another is called parallel connection. Series connection and parallel connection mainly in our day-to-day life we are using for the network connections and all. So that's why first we will learn what is series connection. Series, as you know, series means one after another. The conductors or the resistances must be connected one after another. Suppose consider I have taken three resistors. This is the symbol of resistance R1, R2, R3. I have taken three conductors. This is the starting point and this is the end point. When this R1 is end point, the starting point of R2 is connected. That is R2 is connected after R1 and R3 is connected after R2. So these are connected one after another in continuous process. That's why it is called series connection. And I have applied a voltage V. Because of voltage V, a current is flowing through this circuit. You now see, in series connection, whatever the current is flowing through R1, same current is flowing through R2 and same current is flowing through R3. That means in series connection, current flowing through each element is same. This is the most vital point. In series connection, current in each element is same. Now let us see what about the voltage. Now, when current is flowing through this resistance, there is some voltage drop, against this in R1, and some voltage drop in R2, and some voltage drop in R3. So these are the voltage. We don't know what is the amount of voltage V1, what is the amount of voltage V2, what is the amount of voltage. It all depends upon the resistance of the material R1, R2, R3. So the V1, V2, V3, as I have mentioned, that means the voltage across each element is different. The voltage across each element is different. So what is the conclusion in series connection? In series connection, the elements are connected one after another and the current flowing through them is same through all the elements, but the difference is the voltage across each element, what we say voltage drop across the element is different. V1, V2, V3 are different amount and the current amount is same whatever is flowing through R1 and R2, R3. Now, so the voltage drop across R1 as per Ohm's law, V equal to I into R. So the current is same and it is multiplied by the resistance R1. Similarly, in second resistance R2, though it is series connected, I into R2 is the voltage drop V2. If somebody will ask how much voltage is drop across R1 resistance, then with this, according to Ohm's law formula, we can calculate what is the voltage drop across each element V1, V2, V3. Now let us see, if a big series circuit is given, if they will ask how much total current, how much current is flowing through the circuit. In that case, what we have to do in the whole circuit, we have to make it a total in a single circuit. We will make it a single circuit. That single resistance we call equivalent resistance or equivalent resistance of the whole circuit. Suppose if 10 resistances are connected, we will make them one resistance. That one resistance, in technical term, we said equivalent resistance of all these 10 resistance. Now let us see how we can calculate the equivalent resistance of the series connection circuit, where the resistances are connected in series. As we know, the voltage applied, see the previous circuit, the initial circuit. This is the total voltage I have applied. V1 is voltage drop across R1, V2 is the voltage drop across R2, V3 is the voltage drop across R3. Now, the relation of V is equal to V1 plus V2 plus V3, because this is the total voltage I have applied and this is the process how we can calculate V1, V2, V3. And yes, here I have mentioned that is total voltage is equal to sum of all the voltage drop across each element. Now, as you know, according to Ohm's law, I can write instead of VIR, instead of VI into R1 into R3. Now, I, if I take comma, this is R1 plus R2 plus R3. So this summation of these resistance is called R equivalent, or R, the total resistance of that circuit or equivalent resistance of the circuit is equal to R1 plus R2 plus R3. Now, similarly, in that way we can calculate the total resistance and total voltage by your equivalent resistance will give you the total current flowing through the circuit. Now let us come to the parallel connection. Parallel, as you know, they are parallel to each other. Parallel to each other means, as in mathematics we know, parallel, they don't meet in a particular point. So, but here in electrical circuit, when we are connecting the elements in parallelly, we the two sides of the elements are commonly joined. Here we can show you that these are three elements, three resistance R1, R2, R3 are connected, and all these three starting end is connected here, and the end point is connected here, and the voltage V is applied across the whole parallel circuit, so that the voltage across each element is same. Here, when I am applying the voltage, a current I is flowing, I is coming to this point, then the current has got three directions, three paths. One is this way, another is this way, third one is this way. So suppose if I take the current is flowing in through R1 is I1, and the current flowing through R2 is my I2, and the current flowing through R3 is I3, then I can write the total current I is sum of I1 plus I2 plus I. Same time, the voltage same positive point is connected here, and this negative point is connected here. So the voltage is totally applied across the whole three resistances. That means in parallel circuit, like in series circuit, just opposite to that, a series connection. In parallel circuit, what happens? The voltage across each element is same, whereas the current through each element is different. The live example is in our domestic wiring connection. We have different home appliances and all. Whichever we don't need, we can switch off that particular load, and which other things we can run. Here you can see, suppose if this side connected a switch and this will off, the current will not go through, but these two will run. So that is the parallel connections advantage. That means at a time we can run all the loads, and which one we don't need, we can also that time switch off. That is the difference between series and connection. But in series connection, if you remember that all are connected in series, suppose some fault occurs or somewhere something occurs, then whole circuit current will not flow because of that path is open. Always current flows in a closed path. Here, if you remove this I1, these are the close to R2 and R3 will make closed path with the voltage V. So the current can flow, all these things. And here also in total circuit, I can make it one circuit, that is R equivalent, that is like series one, it has different thing. I can write I equal to I1 plus I2 plus I3, because the current, whatever the total current is going to the circuit, is divided into three paths, I1, I2, I3. So I can write I equal to V by R and I1 V by R1. Voltage is same, so divided by that particular resistance. Again the voltage is same for the second resistance and R2 and V by R3. And by simplifying this, I can write V by R equal to V into this. So 1 by R equal to 1 by R1. This is the formula how to calculate the equivalent resistance of the parallel circuit. And so if you see the problem, if you want to solve the problem and all, three resistors 8.4 ohm, 6.8 ohm and 4.8 ohm resistances are connected across 100 volt supply. What it is asked, find the current, find the total resistance. How to find out? Because it is a series connection. How to know it is a series connection? First you mark the current direction. If the current is flowing through all the elements are same, then we say it is a series connection. So already in problem it is made that the connection is series. So no doubt it is a series connection. First is I have to find out the resistance. Total resistance means R equivalent is equal to R1 plus R2, summation of all the resistance, that is 8.4 plus 6.8 plus 4.8 will give me the total resistance. So when I got the total resistance, if I divide it by the voltage, then I will get the current. Then voltage across each resistor, V1 equal to current into this resistance, V2 current into this resistance, whichever current I have found in the problem, V3 is current into this resistance. Now you can see that also how it is solved. See, total resistance is the sum of all the three resistance, 8.4, 6.8 and 4.8, that is 20 ohm, and the current I equal to V by RQ. REQ means R equivalent resistance. R equivalent, we have got 20 ohm here, and that 100 by 20, you get 5 ampere current is flowing through the circuit, whole parallel circuit, series circuit, 5 ampere current. Now it is third point is asked to how to find out the voltage drop across each element. Each element means R1 how much voltage is taking, R2 how much voltage is taking, R3 how much voltage. So when I am calculating the voltage across R1, I will see how much current is flowing through this R1 and I will multiply with that resistance. So my current is circuit, my current is same, 5 ampere is flowing. So 5 into 8.4, 42 volt. Then similarly, voltage across second resistance R2, 5 into 6.8, 34 volt, and for V3 it is 5 into 4.44 volts. Okay, so these are the series and parallel connection, and I've solved one series problem. So in parallel problem also you can solve it like how the method. Okay, thank you.